Hello everyone, welcome to today's class. Today we will discuss chemistry and that too preparation of hydrogen and laboratory preparation of hydrogen we will discuss. So in the laboratory how hydrogen is prepared, that one let us see. This is the arrangement for this laboratory preparation. Here this is the round bottom flask I have taken. This is the thistle funnel and this is the delivery tube and this is the beehive shelf, and here how this is the gas jar, how hydrogen will be collected. Okay, so here what we are taking in this round bottom flask we are taking zinc granules. Okay, so we are taking zinc granules, and through the thistle funnel either HCl or H2SO4 acid is poured inside. All the cases this one will be dilute. Dilute HCl or H2SO4 is added here. So here if I put the zinc granules here and here H2SO4 will be added to it, obviously this one will be the reaction taking place. This reaction whatever taking place I have written here zinc with H2SO4, you can write HCl also, here ZnSO4 plus hydrogen. If we are taking it is HCl hydrochloric acid dilute, here ZnCl2 with hydrogen it can be taken. Here while taking this laboratory preparation of hydrogen, certain things we have to remember, keep in our mind. Here what thing we should see, this whatever reactants we are taking, reactants should be easily available. First one. Second one, it should be, this reactants should be easily available. Second one, it should be cheap. It cannot be costly. It should not be costly. If it is costly we are taking, then it is difficult for us. No doubt it is, reaction will take place, all these things will be there. But the purpose, that economic purpose also we have to see. So here this should be cheap. And here third point is, it should be safe. Why I am telling this one should be safe? Because instead of zinc, if I will take sodium or potassium, those who are highly reactive elements with dilute sulfuric acid, see what it will be, it is not safe at all. That is why we have to see that these elements or these metals which are safe and easily available and it should be cheap, that one should be taken as the reactants in the laboratory preparation. Okay, then here another thing is, when we are taking zinc should be the granulated zinc. Here it should be granulated zinc. Here granulated zinc we can write, or other name it is commercial zinc. It is commercial zinc. Pure zinc cannot be taken. Here only granulated zinc it is taken. Why granulated zinc it is there? Here copper, traces of copper are there. Traces of copper which act as a catalyst. Okay, that is why only granulated zinc is preferred, or other name it is commercial zinc. Understood? Then here why we cannot take this pure zinc? If we are taking this one, it is pure zinc. Here pure zinc, it is not advisable to take for this laboratory preparation, because whenever we are taking this pure zinc, again reacting with acids, there will be some small coating will be there, and after that one reaction is not possible for them. But if pure zinc, if you want to take, along with pure zinc, if you add copper sulfate, pure copper sulfate solution or copper sulfate crystals can be added, so that the reaction can continue here. Here what can be zinc plus copper sulfate, whatever reaction will be there. Here this one will be ZnSO4 along with that along with copper it comes. Here after that one this reaction continues and here there will be a zinc copper couple will be formed for which reaction continues. Okay, so here another it comes, why if we are taking zinc, why not other substances? Why not other substances we are taking? Because if here we are taking this one, it is if aluminium is there, calcium it is there, barium there, lead there. So all these cases, this barium and all this, we cannot use all these things. It cannot be used because in these cases they form insoluble coating, insoluble coating insoluble coating over these metals, which further stops the reaction. So for the continuation of this reaction, here we have to take this. We have to consider this zinc. It is all the way. It comes proper. Okay, let me rub this one. Now, when we are considering this equation here, now the reaction it is taking place. Now in this case, we are getting here ZnSO4 will be formed. Okay, along with that one here, hydrogen gas will be evolved. One thing you see that when I am keeping this one, this lower end of the thistle funnel should be dipped inside the solution. Why? Here see that one, lower end of thistle funnel should be dipped inside the solution. Why it is should be dipped inside the solution? So that hydrogen should not escape through thistle funnel. Should not escape through thistle funnel. That is why this should be here. It should be kept means inside that solution. Okay. Now another part it is there. When we are taking this, all this part should be airtight. We are considering this should be airtight. Okay, I hope you wrote this one. Now, here in this reaction, this arrangement made airtight. This arrangement is made airtight. Just to avoid of escape of hydrogen. Then what happens if it is escape through this, means escape here? What happens to escape hydrogen? So it forms an explosive mixture with air. Next will be how it is collected. So here collection of hydrogen. How it is collected? It is collected by the downward displacement of water. Downward displacement of water. Okay, so it is collected by the downward displacement of water. How it is possible? See, previously water level was let it be up to this level. When hydrogen it is collected, here it is through the beehive cell, through water. This is the gas jar. Okay, water will be here. When hydrogen it is collected, here it goes. So it will push the water down and hydrogen will be collected here. It pushes water down. As water is pushed down, that is why downward displacement of water it is. Okay, so it creates a space for it, for hydrogen for itself. That is why it will push water will be pushed down, and here now when it will be pushed down, there will be a space for hydrogen. It will apply pressure downward, so hydrogen can be collected in that area. So here question arises, why it is not collected, it is in by air, in air, why it is not collected? Because everybody knows hydrogen is lighter than air. Okay, but it forms, hydrogen is lighter than air. Hydrogen is lighter than air. If it is lighter than air, then why it is not collected over air? Reason is that it forms a explosive mixture an explosive mixture with air. That is why it is not collected over. We have taken impure zinc, or we have taken granulated zinc. It means that these have some impurities which act as catalyst for the reaction or for the preparation of hydrogen. So here, if we are taking granulated zinc, this one it is impure zinc. Yes, if it is impure zinc we have taken, do you think whatever hydrogen will be collected, that is the pure hydrogen? No, this one will be impure hydrogen. Impure hydrogen will be collected. So, if we are talking about impurities, what are the impurities present here? So, impurities present here, maybe it is silver nitrate. It will be nitrogen dioxide. It can be sulfur dioxide. It can be carbon dioxide. Here, then it can be the moisture, because we are taking diluted acid. Okay, here it can also contain H2S. It can contain phosphine. It can contain arsine. Yes. So, what are the impurities present along with hydrogen? If we are taking granulated zinc, these are nitrogen dioxide, sulfur dioxide, carbon dioxide, moisture. Moisture comes from the dilute acids, H2S, hydrogen sulfide, and phosphine and arsine. So, there are different ways how to remove all these impurities and to get this pure hydrogen. So, this step will be for the purification of hydrogen. So, here this is purification of hydrogen, because hydrogen we have taken from the granulated zinc. As we have taken it from granulated zinc, obviously there are many impurities along with this one. What are the impurities along with hydrogen? Here, along with hydrogen, here that one will be phosphine, arsine, H2S, carbon dioxide, sulfur dioxide, nitrogen dioxide, moisture along with hydrogen. So, all this will remove and only hydrogen will be there. This is for the purification. This is known as purification. So, what to do here? We have to take different what you can say, this reagents or solutions we have to take, so that one by one all these impurities will dissolve there, and after that we will have only hydrogen with us. So now let us take first one. Whenever it is collected, it is not necessary now to collect by the downward displacement of water, because whatever hydrogen we will collect here, that one directly can pass through AgNO3 solution. So here it is AgNO3 solution. So why we are taking AgNO3 solution? Whatever this phosphine and arsine there, here phosphine and arsine, they get dissolved in AgNO3 solution. So with us, these two are out. Now, here what we are getting? H2S, carbon dioxide, sulfur dioxide, nitrogen dioxide, water vapors, along with that one hydrogen. All this will pass through the lead nitrate solution. So, lead nitrate solution, H2S will dissolve in lead nitrate solution. So, here H2S will dissolve in lead nitrate solution. Remember this one, try to understand. Here equations are not required for us, only to remember what are the solutions and which gases or which impurities are dissolved in these solutions. So only remember that one. So here when it is passing through PbNO3 solution, H2S will dissolve. So when the H2S will not be there, what else will be there? We have carbon dioxide, we have sulfur dioxide, we have nitrogen dioxide, we have water molecule, along with we have hydrogen which will come outside. Okay, so here when we are taking this one, then KOH solution, here carbon dioxide, sulfur dioxide, nitrogen dioxide will dissolve in KOH solution. Okay, so when all these will dissolve, what else will be outside? We have water molecule along with hydrogen will be outside. Okay, so now only water molecule is there which we have to remove. So for this we have to take an anhydrous calcium chloride. You can take anhydrous copper sulfate also can be taken. In that case white will turn to blue, but here there will be no change in color, but here anhydrous calcium chloride is taken. Here let it be, all these are filled with this. Okay, so this anhydrous calcium chloride will absorb moisture, and what will be outside? Here hydrogen only, this one will be outside, and this is the purified hydrogen. Understood? So here then what else I have not written? Water molecule will be absorbed by anhydrous calcium chloride. So we have to remember this one. Here this is very important for us and you have to remember. Clear? So this one is phosphine, arsine, they dissolve in silver nitrate solution. H2S will dissolve in lead nitrate solution. Okay, so here also I can write this one. This one it can be phosphine and it is arsine. When it comes here, this one will dissolve H2S. When it comes here KOH, so carbon dioxide, sulfur dioxide, nitrogen dioxide. For here I can take water molecule, will absorb. So only hydrogen will be out. So entirely now we are getting this pure hydrogen.